Simplify 45 over 10a minus 10. Well, whenever you're being asked to simplify fractions, what you're usually looking for is to see if there's any number in common in all the numbers that you see. So I noticed that you're divisible by 5, you're divisible by 5, you're divisible by 5. So let's factor a 5 out of everything. So if I factor a 5 out of 45, I'm left with 9. If I factor a 5 out of 10a minus 10, that leaves me with 2a minus 2. Those cross out, like so, and our final answer is going to be 9 over 2a minus 2. And that's your answer. Simplify x plus 6 over x squared plus 5x minus 6. Well, whenever you're asked to simplify a fraction and you have polynomials and stuff like that, you need to factor as much as you can. There's nothing I can factor in the numerator. Nothing at all. However, in the denominator, I can come up with two numbers that add up to -5 and multiply out to -6, and those two numbers are going to be 6 and -1. Okay, now what I see here is on the top I have x plus 6 on its own separate level. On the bottom I have x plus 6 again. Those cross out because they're the same. So if you cross out an entire side, you're left with 1. And what I'm left with on the bottom is x minus 1. And so now it's simplified. Simplify v squared minus 3v minus 40 over v squared minus 11v plus 24. Whenever you're asked to simplify a fraction and you have a polynomial over a polynomial, you're going to have to factor each side as much as you can. So for the top guy, you see a quadratic and you're thinking, all right, well, let's come up with two numbers that multiply out to -40 and add up to -3. So -40 is probably going to be like 5 and 8. Or something like that. So you're going to have an x plus and an x minus. Which one gets the negative, the 5 or the 8? Well, the 8 does because -8, +5 adds up to -3. So that's how you simplify the numerator. The denominator, the same process. Think of two numbers that add up to -11 and multiply out to 24, and that's going to be x minus 3, x minus 8. Now what we have is something times something over something times something. If any of the somethings up here are the same as down here, cross them out. Now you're left with x plus 5 over x minus 3. Now if you're looking at that and wondering, let's cross out the x's, no. Because up here we were saying this times that over this times that, and that's why we were allowed to cross things out. We're no longer multiplying. This is just adding and subtracting. So we're done here. This is the best that we can do. We're simplified. State the restricted values. A restricted value is a number that you're not allowed to plug in because it would make the problem undefined. Well, what makes a problem undefined? If it's over 0. So what I need to do is I need to find out what numbers makes the denominator 0. So I have to find out 6n minus 2 equals 0. So we're going to add 2 to both sides, like so. Cross you out. 6n equals 2. Divide both sides by 6. And n is going to equal 2 over 6 is a fraction that simplifies out to 1/3. So the restricted value is just going to be 1, and it's going to be 1/3. So depending on what teacher you have, you might have a teacher that says, you have to write out n equals 1/3, or you have to write out that n cannot be 1/3. It all depends on the teacher, but the reality is 1/3 makes the bottom 0, which means it's not allowed. That's it. We only care about the denominator, not the numerator. State the restricted values. The restricted values are the numbers that make the denominator equal to 0. So what I need to do is I need to find out what numbers would make this denominator equal to 0. So I'm going to set x squared plus 5x plus 14 minus 14, not plus, minus 14 equals 0. And if you're like, okay, well, when we're done that, we're going to do the numerator, right? Nope, we don't care about the numerator. You don't matter. We just care about the denominator. So this guy is a quadratic, so let's see if we can come up with two numbers that add up to 5 and multiply out to negative 14. So if it multiplies out to negative 14, you're going to have a positive and a negative. So 7 and 2 should do the job. And the 7 is going to be positive and the negative is going to be 2. Okay, because that adds up to positive 5. So you have x plus 7, x minus 2. Now this is the zero product property. So each factor is going to be equal to 0. So x plus 7 equals 0, x minus 2 equals 0, subtract 7, x equals negative 7, add 2 over here, add 2 over here, x equals 2. So my restricted values are going to be negative 7 and 2. So those are the numbers that would make the denominator equal to 0. Again, we don't care about the numerator. The numerator is allowed to be 0. You're just never allowed to divide by 0 because that makes it undefined. So the two numbers that would make it undefined would be negative 7 and positive 2. All right, simplify 93 over 21n times 34n over 51n. Whenever I'm being asked to simplify two fractions with a lot of stuff going on multiplied together, what I want to do before I do anything is factor out as much as I can. Okay, see if these numbers rip apart and turn into anything. So for example, like 93 is 31 times 3. So let's turn and let's do this. Let's use all the colors that we have. 93 is going to be 31 times 3. 21 is going to be 7 and 3. N comes along for the ride. We've got over here 34, which is going to be 2 and 17. So 2, 17, and then n comes along for the ride. And then 51 is going to be, what is that, 3 and 17? And then n comes along for the ride. When you multiply fractions, right, you just basically multiply the top and the bottom. So that essentially happens. And when you're just multiplying straight across the top and straight across the bottom, anything in the numerator that's the exact same as the denominator crosses out. So these n's right here cross out, these 17's cross out, these 3's cross out. Anything else? No, I think that should do it. So what that leaves us with upstairs is 31 times 2. And what that leaves us with downstairs is 7 times 3 times n. So at the end of the day, we get 31 times 2, which is 62, over 7 times 3, which is 21, n, which comes along for the ride. Interesting. Very interesting. Simplify 7n squared times n plus 4 over n minus 3 times n plus 4, all times n minus 3 all over n plus 8 times n plus 6. All right, so this is a friendly version of what terrible things are about to happen. When you're multiplying two fractions, basically what you're going to want to do is multiply everything together. Okay, let's wrap u in parentheses. Now when you multiply two fractions together, and if all you're doing is multiplying across the top and multiplying across the bottom, you're allowed to cross things out if the stuff up top and the stuff on the bottom are the same. For example, n plus 4 and n plus 4 cancel out. N minus 3 and n minus 3 cancel out. Now what that leaves us with is 7n squared in the numerator and n plus 8 times n plus 6 in the denominator. Now, in order to really simplify this, what we ought to do is FOIL out the bottom. So let's leave 7x or n squared in the numerator all alone. N times n is n squared. N times 6 is 6n. 8 times n is 8n. And 6 times 8 or 8 times 6 is going to be 48. So to wrap this guy up, we still have 7n squared in the numerator. These two combine, so we have n squared plus 14n plus 48. And that's going to be our guy. Simplify 1 over p minus 9 times p squared plus 6p minus 27 all over p plus 9. Whenever you're multiplying two fractions together and you see polynomials, what you really want to do is factor as much as you can. There's nothing I can do about 1 over p minus 9. That's done. But what I can do is p squared plus 6p minus 27 should factor out the two numbers that multiply out to negative 27 and add up to 6. Those two numbers would be p plus 9 and p minus 3. That's going to be all over p plus 9. Now, if we're multiplying fractions, we can essentially extend that bar and say, all right, well, 1 times p plus 9 times p minus 3 is p plus 9 times p minus 3. And on the bottom, we have p minus 9, p plus 9, p minus 9, p plus 9. Since all we're doing is multiplying this times that over this times that, anything that's in the numerator that's the exact same as the denominator crosses out. That leaves us with p minus 3 over p minus 9. Now, if you're looking at the equation and you have p minus 9 over p minus 3 over p minus 9, and you're thinking, let's cross out the p's, you can't. And the reason why you can't is now you're adding and or subtracting, and those won't cross out. You can only cross things out when you're multiplying. So since we're saying parentheses times parentheses over parentheses times parentheses, we can cross out the parentheses. We're not doing that anymore. So that's going to be our answer. Okay? Tough stuff. Simplify 5 over 20 divided by 5x over 3. Well, first off, 5 over 20 simplifies out to 1/4. Let's take care of that. Now, instead of dividing the fraction, let's multiply the reciprocal. So change, flip. All right, so now we can multiply straight across the top. 1 times 3 is 3. Straight across the bottom, 4 times 5 is 20. X comes along for the ride. Looking at that, nothing else simplifies, and that's going to be our answer. Simplify 6 over 28x plus 4 divided by 6 over 35x plus 5. If you notice right away that you're dividing a fraction, rewrite it, and instead of saying divided by a fraction, say this, multiply the reciprocal. So 35x, not 3x, oh, that's a close one. 35x plus 5 over 6. Now, if you're multiplying fractions and you notice that there's something in the numerator that's the same as something in the denominator, cross those out. Now, that's going to leave us with invisible 1 times 35x plus 5. So let's write out 35x plus 5 all over 28x plus 4 times invisible 1. Now, it's tempting to be done, but I don't think I am. And the reason why I don't think I am is I notice that I can factor a 5 out of this top equation. So let's see what happens when I do that. If I factor a 5 out of the top expression, that leaves me with 7x plus 1. I also notice that I can factor a 4 out of the bottom expression. So if I factor a 4 out of the bottom expression, I'm left with 7x plus 1. 7x plus 1 and 7x plus 1 are the same. They cross out, and we're left with 5 over 4. Ooh, tricky, tricky, tricky. Simplify b squared minus 2b minus 15 all over 8b plus 20 divided by 2 over 4b plus 10. Well, before I do anything, why don't I rewrite this as me keeping the same exact original first fraction like this, and instead of dividing the fraction, multiply its reciprocal, like so. Now what I can do is, if I have polynomials all over the place, knowing very well that this is a fraction and we're just going to end up multiplying these guys anyway, like this, why don't I try to factor as much as I can? So if I look at b squared minus 2b minus 15, that's a quadratic, and two numbers that add up to negative 2 and multiply out to negative 15 are going to be 5 and 3. So if I make u b minus 5 and b plus 3, the top left factors out to that. The bottom left, I have an 8b and a 20, which means I have a 4 in common in both. So if I factor out a 4, that leaves me with 2b plus 5, inside the parentheses. Similarly over here, I notice, for b and 10, I can factor out a 2. That leaves me with 2, and then 2b plus 5. And on the bottom, I just have a regular 2. So what color didn't I use yet? Black. So if I see that I have stuff in the numerator and stuff in the denominator that can cross out, let's cross them out. That 2 can cross out, that 2 can cross out. That 2b plus 5 and that 2b plus 5 can cross out. And I'm left with this. So I'm left with b minus 5 times b plus 3 all over 4. Now I know that b minus 5 and b plus 3 just reverts back to b squared minus 2b minus 15. So if you're looking at that saying, then why did we do it in the first place? Because you never know if it's going to turn into anything. In this case, it didn't. But that's going to be my answer. Not the prettiest thing in the world, but we did it. Divide using synthetic division. So I have n cubed plus 7n squared plus 14n plus 3 divided by n plus 2. Synthetic division means you take whatever you're dividing and use the opposite root and put it in that little box right there. Then you're going to create a little box, or a bigger box rather, and use the coefficients from this guy to make those numbers. So invisible 1, 7, 14, and 3. In synthetic division, the first step is to always drop down the first number. Take that number and multiply it to your root. So 1 times negative 2 is negative 2, and place it underneath the next number. Add these two numbers. 7 plus negative 2 is 5, and then repeat the process. 5 times negative 2 is negative 10. Add the numbers. 14 plus negative 10 is 4. 4 times negative 2 is going to be negative 8. Add the numbers. 3 plus negative 8 is negative 5. Now the way I set my answer up is I go from the non-remainder number and put nothing there. I then take my 5 and attach an n there, and take my 1 and attach an n squared there. You're positive, so let's make you a plus sign. You're positive, so let's make you a plus sign. And what do I do with that negative 5? Well, let's add negative 5 over the guy that I originally divided. So this looks sloppy. So let me write this out in one final swoop over here. That 1 isn't necessary. N squared plus 5n plus 4. And let's pull out the negative and make that minus 5 over n plus 2. Some teachers might be okay with you saying remainder negative 5, and if that's the case, then that's the case. But in this case, if I really wanted to do everything, my answer would look like that. Divide using synthetic division. Well, in order to do synthetic division, I have to put everything in order first. So I'm going to make this k to the third minus 4k squared minus 30k minus 18 divided by k plus 3. Everything's in order. Now to set up synthetic division, what you're going to do is you're going to put the opposite root in here, so negative 3, and you're going to write out these coefficients in order. So your invisible 1, negative 4, negative 30, negative 18. Drop down the 1. So synthetic division, the first step is to always drop down the first number, so drop down the 1. Take that 1, multiply it to your root, and put that directly underneath the next number. Take these two numbers and add them. Negative 7, repeat the process. Negative 7 times negative 3 is positive 21. Negative 30 plus 21 is going to be negative 9. Negative 9 times negative 3 is 27. Negative 18 plus 27 gives me a remainder of positive 9. Now, in order to set up our answer, we start out with the non-remainder number and attach nothing. Then we attach a k, in this case, and then we attach a k squared. Okay, so your negative is already there, the negative is already there. My remainder was 9. So the way I put my remainder there is some teachers might be okay with you saying remainder 9, or you can write out plus that 9 over what you originally divided by 3 plus k. So if I wanted to, I can rewrite this out as this, because 1k squared is useless. K squared minus 7k minus 9 plus 9 over 3 plus k plus 3. It's all good. It's all the same. That's going to be our guy, and we are going to be done. Simplify u plus 5v over 8v squared u squared minus u minus 6v over 8v squared u squared. If you're subtracting fractions of the same exact denominator, just subtract. So I have 8v squared u squared on the bottom, and here I have u plus 5v minus u minus 6v. Yes, you put that in parentheses because yes, you have to distribute that negative. That makes it tricky. So up here I have u plus 5v minus u plus 6v. That's going to be all over 8v squared u squared. Combine like terms, u minus u, cross out. 5v and 6v is 11v, and that's going to be all over 8v squared u squared. Now before we call it a day, I notice that I have nothing but multiplication up here and multiplication down here. I have a v up here and two v's down here. Cross out one v on each side, and that leaves us with 11 over 8v u squared. And that's going to be our guy. Simplify 8 over 7v minus 6 plus 4 over 3v squared. Now, whenever you add fractions and the denominators are not the same, you need to make them the same. So in this case, what we're going to have to do, and it's not going to be pretty, is since this denominator is 3v squared, I'm going to multiply this first fraction by 3v squared over 3v squared. Yuck, yuck, yuck. I'm going to have to multiply this fraction by 7v minus 6 over 7v minus 6. So what's going to happen is you multiply these two guys together. Okay, so 3 times 8 is 24v squared. Okay, this guy, multiply these two together, we're going to end up with, well, actually, let's wait. Let's just wait to multiply them through, because maybe something magical will happen. Every now and then when you do these, something magical will happen, so I'm going to wait. We'll leave that be. Now, if I multiply 4 times 7v, that's going to be 28, the distributive property, and then I'm going to have 4 times negative 6, which is negative 24, all over 3v squared 7v minus 6. Now that the denominators are exactly the same, I can combine these fractions, and nothing magical is going to happen. I have 24v squared plus 28v minus 24, no combining like terms. So what I really should do now is, now that I know that that's 3v squared times 7v minus 6, distribute that. So that gets me 21v cubed, and 3v squared times negative 6 is going to be negative 18v squared. So, yeah, definitely not the prettiest princess on the planet, but yeah, that's how you do it. Simplify 4x over x plus 3 minus 4x over x plus 6. Now, if you're being asked to add or subtract fractions, the denominators have to be the same. Well, they're not. This is x plus 3, and that's x plus 6. Those are not the same. So the way you fix that is you take that denominator right here and multiply the other fraction by the denominator over itself. X plus 3, x plus 3. Similarly, you take this denominator over here and multiply that to x plus 6 over x plus 6. Now what you have is this. So let's actually multiply it out, or like write it out. So I have x plus 6 times 4x over x plus 6 times x plus 3 minus, so this is what I'm going to do. Well, minus, let's do this, 4x plus 3 over x plus 6 times x plus 3. Let's distribute. 4x times x is 4x squared. 4x times 6 is 24. 4x times x is 4x squared. How nice. 4x times 3 is 12x. And that's going to be over, let's FOIL this out, x times x is x squared. X times 3 is 3x. 6 times x is 6x. And then 18. And then we're going to get literally the same exact thing over here. X squared plus 3x plus 6x plus 18. Now that the denominators are the same, and by the way, the denominators simplify out to u. Now that they're the same and they simplify out nicely, I can say 4x squared plus 24, distribute the negative, so minus 4x squared, how nice, minus 12x. The 4x squared minus the 4x squared cancel each other out, and we are left with 24 minus 12x all over x squared plus 9x plus 18. Yuck, yuckity, yuck, 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 gross, gross, gross. Solve 3 over m squared equals m minus 4 over 3m squared plus 2 over 3m squared. Well, what I notice right away is these are two fractions being added together and the denominators are the same. So do nothing with the left side. And on the right side, since the denominators are the same, just add the stuff on top. So you have 3m squared on the bottom. I have m minus 4 plus 2 is going to be m minus 2 when you simplify. Now, what I have is I have a proportion. Crisscross applesauce, cross multiply and divide. So I'm going to have m squared times m minus 2 equals 3 times m squared. So 9m squared. Multiply this guy. M squared times m squared is m cubed. M squared times negative 2 is negative 2m squared, and that's going to equal 9m squared. Let's subtract 9m squared from both sides. Minus 9m squared minus 9m squared. And what that does is that leaves me with m cubed minus 11m squared equals 0. Now I notice that right away I can pull out an m squared, and that leaves me with m minus 11 equals 0. Using the zero product property, I can say m squared equals 0 and then solve that, and then m minus 11 equals 0 and then solve that. Okay, to get rid of the squared, you square root both sides, and whenever you square root both sides to solve, you have to attach the positive or negative. So m is going to equal positive or negative 0, which is stupid because that just means m is equal to 0. Over here, I'm going to add 11, and 0 plus 11 is 11. So if m equals 11, then m equals 11. So my possible answers here are going to be 0 and 11, except I'm not allowed to have 0. Why? Well, if I were to plug in 0 on the bottom, that would make u undefined, and u undefined. So 0 is not an option. So my only possible answer for all of this is going to be m equals 11. Okay, you ready for probably the most brutal problem you can see in Algebra 1? Here we go. Okay, we have this fraction plus that fraction equals that fraction. What I need to do is I need to factor the denominators as much as I can. So I'm going to leave u the way you are, 5x minus 20 over, factor this out. When you factor this out, two numbers that add up to negative 9 but multiply out to 18 are going to be x minus 6 and x minus 3. Plus 1 over x minus 6 equals x to the 4th not x to the fourth, x minus 4 over this guy and this guy are exactly the same. So x minus 6, x minus 3. Now on the left side, I am adding fractions. The denominators are not the same, but in order to make them the same, all I have to do is multiply this guy by x minus 3 over x minus 3, and now all of my denominators will be the same. So you stay 5x minus 20 over x minus 6, x minus 3. You are now 1 times x, so plus x, and 1 times negative 3, minus 3, over x minus 6, x minus 3, equals x minus 4 over x minus 6, x minus 3. Now that you have the same exact denominator, we are allowed to add these up. So 5x minus 20 plus x minus 3 all over x minus 6, x minus 3. That's going to equal x minus 4 over x minus 6, x minus 3. What I can do is I can get rid of these denominators. Okay, these denominators aren't necessary anymore because if I have something over a denominator equals something over the denominators are not necessary. Since these are the same exact denominators, I don't need them. So I have 5x minus 20 plus x minus 3 equals x minus 4. Combine these like terms. That gets us 6x, combine these like terms, minus 23 equals x minus 4. Subtract x, 5x minus 23 equals negative 4. Let's rewrite it up here, which is probably what I should have done in the first place. So I have 5x minus 23 equals negative 4. Add 23, that gets us 5x equals, what is that, 19? Ugh. Divide both sides by 5. And x equals 19 over 5. Very awful, very gross, very painful, but we're done.